So this video is about scatterplots, and a scatterplot is just a plot of a bunch of individual data points of one variable versus another, and it's very useful to get an impression of how one variable might be affected by another variable. So as an example, I have a dataset array here called patients that I've pulled into MATLAB, and it's actually a fictitious dataset. But it has information on 103 patients in terms of gender, age, weight, whether the person is a smoker or not, and systolic and diastolic blood pressure measurements. So I'm going to do a scatter plot where I have weight on the x-axis and have systolic blood pressure on the y-axis to try to see if there's some sort of a relationship between patient weight and systolic blood pressure, and I'll do this using a scatter plot. The MATLAB function used to create a scatter plot is called scatter. My first argument is going to be what I want on the x-axis. My second argument is going to be what I want on the y-axis. Remember, this is a data set array called patients, so patients.weight would be the columns of weights. Patients.systolic would be the columns of systolic blood pressures. And if I go ahead and execute this command, I get a rather messy looking scatter plot. Not really seeing any trends here, so let's look at another scatter plot function in MATLAB called gscatter, which is short for group scatter. The gscatter command actually has three arguments. The first argument is what goes on the x-axis, second argument y-axis, and the third argument is how you want to group the data. So again, I'm going to put weight on the x-axis, I'm going to put systolic blood pressure on the y-axis, and I'm going to group by whether the patient indicated that they were a smoker or not. And if I execute that command, I now see I have a scatter plot that has two colors. All of the blue dots correspond to the patients who indicated that they were not smokers, and all of the red dots correspond to patients that indicated that they were smokers. So from this graph, it looks at least visually that smoking affects systolic blood pressure. Now, if we would not be able to draw such a conclusion by looking at a graph, we would have to do more sophisticated statistical analysis involving hypothesis testing and a large enough sample of patients. So I want to show you one more nice tool that MATLAB has that we haven't yet looked at. If I come up here and I click on Tools and I go down to the very bottom option here, which is Data Statistics, I can see I get this little window open up, and it gives me actually the stats for the data that I have plotted. This works with plots too, it's not just with scatter plots. And so I can see right now my statistics are for the people that were smokers. If I wanted to look at the non-smokers, I could look at the no group. On the y-axis I have systolic blood pressure, and I actually can see what the mean and the max pressure is. The mean is 119, about the same as the median. Standard deviation is 6 with a range of 43. The x-axis data is the weight. So I can see for my non-smokers the mean systolic pressure is 119. If I switch back and I go to my smokers, I can see that the mean systolic pressure there is 129. If I want any of these lines to be graphed on my figure, I can just go ahead and click on whatever I would like to see. So I can see now I've got the mean line plotted at 129, and then I have one standard deviation above that and one standard deviation below that plotted there.